Okay, this is 5-1 mid-segment. Now if you remember, we are in Unit 4, which is all about triangles, and I said the first part of Unit 4 is all about special properties and special segments of triangles. Yesterday we talked about the triangle angle sum theorem and the exterior angle sum theorem. Make sure you know those learning goals. Can you apply the triangle angle sum, and can you apply the exterior angle theorem? Today we're going to be doing the mid-segment, and that there is a theorem that goes along with it. So it's the definition and the theorem that you're going to be learning today. Alright, let's talk about triangle. How do you create a mid-segment? Okay. You've heard the word mid before. Midpoint. We're going to be using midpoint to find our mid-segment. So I'm going to do a paper folding activity to show you what a mid-segment is and to demonstrate the theorem. Alright, to find a midpoint using paper folding, you just take one corner and fold it up to the other corner. Pinch it off, and that is the midpoint. Take this corner up to that one and make your pinch, and that is your other midpoint. Okay. Now, where those 2 points connect, is my mid-segment. Okay, so this will be my mid-segment. These are midpoints, which means that segment is congruent to that segment, and that segment is congruent to that segment. Okay. One of the properties of a mid-segment, one of the parts of the theorem, there's two parts to the theorem. Part 1 is that the mid-segment is parallel to the base. So that means this line is parallel to that line. Okay? Now, keep in mind, base does not always mean bottom. Okay? Could my triangle look like this? I could have done my triangle like this, right? In which case this would be the mid-segment and this would be its corresponding base. Okay? So really, any of the sides of the triangle can be called a base. It just depends on how you're looking at it. Okay, but the mid-segment is parallel to the base. Alright, the second part of the theorem I'm going to demonstrate. Okay, I'm going to fold this part down. I'm going to fold this part in. And I'm going to fold this part in. What I want you to notice is that this distance right here, if you notice, let me trace this out. Okay, if you see what I did, that paper folding was to demonstrate that this length is always going to be twice as big as this length. And so take a look at it again. If you notice, here's a triangle. If I fold it over, that means these two are the same length, right? And if I fold this over, those two are the same length. So if I take this length and this length, and I double them, I get the entire length. And this length is equal to that length. So that means the total length has to be twice as much as this. Okay? For those of you that are really visual people, that probably helped you understand it a little bit. I know that might have been confusing to some. If that was confusing to you, just remember the theorem then. The base is 2 times the midsegment. Okay? Alright. I'll tape that in later. Alright. Your first example. Okay? Let's say you're an engineer and you have a lake and you want to know the distance across the lake. So you want to know how far it is from here to here. Now, you going to swim across the lake and measure it? Have somebody hold the tape measure on one side and swim the tape measure all the way across the lake? Probably not. So, what you're going to use is you're going to use this theorem to help you measure the distance across the lake. Okay? What you're going to do is you're going to pick a point out here in the field somewhere. So you're going to put a little flag there in the ground so you have it marked. Okay? And you're going to walk from your flag to that point. And you're going to measure the distance. Let's say you measured 50 feet. And you're going to start back at your flag. Let's pretend there's a bridge there. I didn't draw my lake good, but pretend there's a bridge there. And you're going to go from here to there. And let's say you measured that to be 60. Okay. So then you're going to go and you're going to start from here and you're going to walk 50 more feet. And you're going to start from here and you're going to walk 60 more feet that way. You put flags in the ground. Then you're going to walk this direction. And let's say you measure this to be 100 feet. How far does it cross the lake then? Well, according to this theorem, this has to be twice as much as that, right? So my 100 feet is equal to 2 times the midsegment. Divided by 2. So it is 50 feet across my lake. So anytime it's something too big to measure, you can actually use this theorem and measure around it, a triangle around it, and use the midsegment theorem to figure out the lengths. All right, one more example. It's going to be short notes today. Let's say this is x plus 2, and that's 5x minus 1, and I want to find x. Again, use the formula, use the theorem. My base is equal to 2 times the midsegment. Right? My base is 5x minus 1, and my midsegment is x plus 2. If you want to solve this by hand, you would distribute, subtract the 2x, add 1, divide by 3, so my x is equal to 5/3. Of course, you could always do this on the calculator. Menu 3, 1. Okay, that's it. That's all your notes. Less than 10 minutes today.